Welcome or welcome back at C Squared. In this lesson, we will talk about the distance between parallel lines. And you see here we have three examples of two parallel lines: a vertical lines, horizontal line, and these two lines that are neither neither vertical nor horizontal. And I said here, parallel line do not intersect, and you can take a look to parallelism by looking to the distance between two parallel lines. For example, if you take a look to these two lines, the distance, which is this segment, which is perpendicular on both, is the same wherever you are. The same wherever you are. The same wherever you are. Okay, in fact, you can see better in my next picture right here. All those are the same. The distance between two parallel lines is the perpendicular distance between one of the line and any point on the other line, I said here. Moreover, two lines are parallel if and only if, that is a strong biconditional statement, they are equidistant. Equidistant means the same distance. One more time, this picture, you notice these two segments are the same. Equidistant. These two segments are the same equidistant, and these two segments are the same. That's what I mean by equidistant. So that means the line are parallel lines. And like I said, that statement works both ways, the biconditional. Another theorem here, if two lines are each equidistant from a third line, then the two lines are parallel to each other. So what do I mean by that? Look at here. I have these two lines are parallel lines or equidistant, L and M, over from a third line, with this one, L, M, and N. Then the two lines are parallel to each other. So if L parallel with N and L parallel with M, let's say like that, then M and N are parallel. That's what it says, this theorem. And you can have all kind of combination, but that is pretty much what it says. Let's see a couple examples how to find the distance between parallel lines. And I'm going to start with these two examples. These are the easy one. We have two vertical lines. The distance is this segment. You just need to count 1, 2, 3, 4, 5. The distance between these two lines is 5 units. What about this one? Very similar. We can draw this segment, or vertical segment in this case. It will be the perpendicular segment on both lines. And we have 1, 2, 3, 4, 5 here. So the distance is 5. So whenever you have vertical or horizontal line, it's easy to find the distance. How about something like this, ladies and gentlemen? First of all, we want to draw the perpendicular line on both lines here. So for that reason, you want to first find the slope of any of these lines. So let's say we look to this line, L. So what will be the slope? We can pick any two good points like this one, see, where we can see the coordinates, and draw this slope triangle. And you notice the slope of this line, L, will be, the rise is 2, the run is 1, 2 over 1, and is positive because it's going up from left to right. So now the question is, what will be the slope of the perpendicular line on L? And then the slope of the perpendicular line will be the negative reciprocal, the opposite reciprocal of 2 over 1. So we're going to flip it, 1 over 2, and change the sign, negative 1/2. So from any of these points, you can go using that slope. So let's take a look. 1 and 2. 1 and 2. You notice this will be a good way to find the distance. I can do the same thing from here. 1 and 2. 1 and 2. And you notice we get another one. And you notice these two segments are congruent, they have the same measure. Okay, we need to find one of them. So again, I'm going to use a graphical approach since we have the graph, and I'm going to use this triangle. Of course, you can use any other triangle that is like this, and let's count 1, 2, 3, 4. This is 4, this is 2, and we can use Pythagorean theorem because this is a right triangle. 4 and 2, and we need to find this c. So we have a squared plus b squared equals c squared. That will be 4 squared plus 2 squared equals c squared, and that will be 16. 4 squared is 16, 2 squared is 4, that will be c squared, and that will be c squared equals 20, or c equals square root of 20, which is nothing else. If you can, we can simplify to square root of 5. But this c, ladies and gentlemen, is the distance. I'm gonna call it d between these two lines, two parallel lines, to square root of 5 units. If you want to simplify this one, I have 4.47 on my calculator. The way will be good. This distance is 4.47, or 2 square root of 5, and the other one is the same thing. And you see the graphical approach works very nice here. Sometimes that doesn't work, or you do not have the graph, so you can still find the distance between these two segments. I show you here the 3 steps you need to follow to get that distance. First of all, I said on step 1, find the equation of the line that is perpendicular on line M. So we need to find the line that is perpendicular on that line M, but also goes to the y-intercept. So for that reason, I'm going to look here. I'm going to look to this line. The slope is -2. This value, and the y-intercept B is 3, which gives me the point 0 and 3. I'm going to need that in this step 1, because now for the perpendicular line, I'm going to take that slope. I'm going to call it M1 now, -2. Let me put M1 here. I'm going to flip it, and I'm going to have -1/2, and I'm going to change the sign. That will be +1/2. That's the slope of the perpendicular line. Let me write it like this: 1/2, and the point that it is going to go through is 0 and 3, the same point, the y-intercept of line M. So now we can use the point slope form. Y minus y1 equals m times x minus x1. So I'm going to have here y minus y1 is 3. Well, in fact, we can really use y equals mx plus b here, because we have the y-intercept. We don't really need that, so let me erase this. And we have y equals, the slope is 1/2, so 1/2 x plus b. B is the same, 3, right? So this is the line perpendicular on line M, and I call it that line L. Okay, find the intersection between line L, this one, and line N, the one that is right here. This is my second step, so I'm going to copy this. Y equals 1/2x plus 3. This is line L, and y equal -2x minus 1, the line N. So this is a system of equation, and we can use substitution here, and we get 1/2x plus 3 equals -2x minus 1. I would personally like to get rid of the 1/2, so that's the reason I'm going to multiply by 2 both sides, and I'm going to get here 2 times 1/2, that is 1x, or just x plus 3 equals -4x minus 2. So again, distributive property in this equation to get rid of the 1/2. Now I will add 4x to get rid of the minus 4x. And I will subtract 3 to get rid of plus 3. So let's see what we get here. We get 5x, x plus 4x equals, and I'm sorry, here we was 6. Let me erase. I did a mistake here. I can see now. Sorry. So we have 2 times 1/2, that is 1x. And 2 times 3, that's the mistake, 6 here. And the other side was correct, negative 4x minus 2. So like I said, here I'm going to add 4x on both sides to get rid of the minus 4x. Of course, this is not the only way to do it. Minus 6 to get rid of this plus 6. And let's see what we get. We're going to move right here. Now we have x plus 4x, that is 5x. And then we have negative 2 minus 6, negative 8. So we're going to divide by 5 and we have an x of negative 8 over 5. Now we can move and find the y coordinate. For the y coordinate, I think I prefer to use this second because we don't have a fraction, and that will be negative 2 times negative 8 over 5 minus 1. This one here, I will say it's 5 over 5. Would be better to work with this fraction. So that will be y equals 2 times 8, 16. Everything is positive now because we multiply to negative number, minus 5 over 5. So I end up here with 11 over 5. 16 minus 5, 11. So we know now the point. The point is negative 8 over 5 and 11 over 5. This is the intersection point between the line L and N. And now we can find the distance between this point. Let me call it D, and D, I said here the y-intercept of line M, if you remember this one, let me call it C. Okay, so the distance formula between is square root of x2 minus x1 square plus y2 minus y1 square. It's up to you which one is 0.1, which one is 0.2. I'm gonna use this one as 0.1, so x1, y1, and this one 0.2, x2, y2. So let's see what we get. We here, but again, you can switch them, no problem. X2, so that will be negative 8 over 5 minus 0, right? Okay. That will be x1, 0, plus y2. y2 is 11 over 5 minus 3. Okay, square, don't forget the square. Let's move here now. Let's do some simplification in this square root. And we have here negative 8 over 5 minus 0, that is negative 8 over 5 squared, plus, and now here we can change that to 3 in 15 over 5, and then we have 11 minus 15, that is going to be negative 4. Negative 4 over 5 square. Okay, so couple more steps. D equals square root of, if we square negative 8 over 5, that will be 64 over 25. And the other one, it's a negative, but square becomes a positive 16 over 5. So one more step. Now we can add those two fractions, 64 plus 16, that is 80. 80 over, and I'm sorry, here it's 25 because we square it, 80 over 25. And you can simplify this one. Square root of 80 will be 4 square root of 5. Square root of 25, it's 5. So this is the simplest form. Now if you want to evaluate, you're going to need a calculator. I did that and I end up with 1.79 and round it probably to the nearest tenth, I guess 1.8 if you need that. Okay, so these two will work. If you want to see, that's the thing we did algebraically. We found the distance. We found this guy. We found this distance. Okay, we found the intersection point and then we use the distance formula, and that's it. We could have approached in the other way, use the line n, write the equation of the line that is perpendicular on m and goes through this -1. This guy will be the same. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.